Alright, in this video I'm going to talk about some of my design parameters for this thing. So I just showed you how I made this 8x12 by 3.5. Now I want to show you how the file works. So let's open that up. So just real quick, the way that the tube seals and the caps is in this trepan groove, and I've actually only ever seen that in writing, so I may be pronouncing that wrong. But this trepan groove, I think it's default to the same as the wall thickness of the cylinder, and obviously that's a little bit shallow. So actually, like when you use an O-ring with that same diameter, that's going to be too thick. So we may end up using, God help us if this design ever gets manufactured, then we may end up using a flat gasket here instead of an O-ring there. And obviously the dynamic seals are wiper cups. So yeah, I guess I can talk about that. The way I do not recommend doing this, but the way that I created the U-cup for this file was by taking this, basically tracing this out, and then setting all of the points. You can't do an ordinate dimension in this. I'm used to doing that in SolidWorks, where you would just have a reference line. Say your baseline would be your reference line, and then you could do all the y coordinates in reference to that baseline. That's ordinate dimensioning. But I don't have that in SolidWorks, so it comes out really ugly. But it's all based on like height. So like here's what the sketch looks like. And once again, I really, come on, where you at? Oh, I need to make it visible. There it is. Okay. You can just see how many dimensions there are. So that needs to get fixed. Really this could just be, for our intents, it could just be a symmetrical image, like a V. It doesn't need to have this complex geometry. And it really doesn't need all these dimensions, because that just slows everything down. I haven't noticed any problems, but sorry about the noise. Anyway, so yeah, we kind of start with the cylinder, and we start with the bore. I actually recently changed that. I had been referencing the outer diameter, so there may be some things which don't really make sense yet. I think I caught them all though. But we start with the bore, and I don't know why I'm going all crazy with my view right now. But we start with this sketch, and our bore is given by the tube radius in our spreadsheet. So, and then obviously the outer diameter is just that plus the wall thickness. You set the wall thickness in the spreadsheet. So, yeah, we start with the tube, and the extrusion of the tube is based on the stroke you defined in the spreadsheet, because you need to accommodate the piston and the stroke, and then there's also this little bit of part that goes into the cap. So that's in there too. And then we move to the caps. The base cap is pretty simple. It's just a square. The circle, the tie rod circle pattern, we use the hole spacing here, and everything is square. It makes things simple. But this hole spacing is equal to the outer diameter of the cylinder. That's just a simple way to do that, and there are others. That may be something that you want to tweak when you generate your model. And then I just gave it a 1/4 inch chamfer, and you set the length of that in your spreadsheet. And then you've just got the bore for the fluid and the tray pan groove for sealing the tube. And that's all you need for this end. The other end's obviously more complicated because you've got a rod going through it. So if we move up to that guy, he's got a couple seals on the inside. And you don't worry about this big bore here. It's just, I have a dumb equation setting that. So our bores here, I guess we call it a bore, but our grooves, our internal grooves for our seals, the way I did those sketches, and I have to move to wireframe. So these two grooves, the two sketches are just copies of each other, and I just turned the one I'm not using for that that groove into construction mode. But you can see I've got both of them there. And what did I do? I set a construction line at my inner diameter minus 5 thousandths, just so that we would be sure, because there's the 5 thousandths gap right there. And then I set the distance between these two to be equal to, it has something to do with the length of the thing. Yeah, the pad length. So let's say you make the cap thinner. These will just move 1/4 of that length off of the center. And obviously that, when you get to the extremes, you're going to have to play with that because your grooves won't generate. But that's the only difference really between that and the cap. You have to watch out for this bore here, because you've got this. Let's do that. Here. You've got this internal edge here. I can't select a hidden line, but there we go. You got this internal edge here and this one here. So the positioning for this is, it's centered between these two. And then the size of it is just 75% of that. And that worked for the small ones. It doesn't really make sense for the big ones. Moving on. That's our cap. And now let's go to the piston and the rod. In this design, these are just welded. So I put a chamfer in down here. Yeah, that's... basically you would just have to make sure that this is a good weld, or it's a press fit so that you don't have fluid loss between there. If you look at a real cylinder, like if we go to my log and look at this image here, you can see that there's a seal on the inside. That's piston static seal. So, that's something that we'll have to look at whether it's worth. I mean, I don't know. I know that there's talk of buying these rods pre-manufactured, which would be a good idea. Obviously, probably not going to make it out of cold rolled. So they may come threaded, and this whole thing might look different. But this just gives you a good approximation that welding that's kind of consistent with what we do at OSE. So there's the rod, and the rod length is parametrized. It has to do with the stick out you set, the cap thickness because it has to pass through the cap, the piston thickness because it has to get to the bottom there, and then the stroke. So, oops, that's all. And then the piston itself, you set the thickness in the spreadsheet, and then the seals, you can also set those. And I believe that there's a similar thing going on there, where, yeah, I did the same thing. I've got my construction geometry, and we're referencing why. Yeah, okay. There it is. So I guess I just pulled an external. Oh, that's the origin of the part. Yeah. So this is actually drawn on the XY plane, or the XZ plane, and revolved around the origin, or revolved around the Z, as opposed to the cap. Which one was that? There was one thing where I revolved it. Okay, yeah, with the seals, I revolved it around the. So with the seals, I did something different, and I'm not really a fan of what I did with the seals. You can see there's all those dimensions, but with this drawing, the origin is down in the corner of this, like right here, and I drew a construction line right here. So that's how I set the diameter of that piston seal, or just whatever any of the wiper cups. Just use a construction line. That's actually a really cool feature of FreeCAD. That it'll know, like it'll say construction line 1. Let's revolve it around construction line 1. Yeah, see that? You just draw a construction line and it'll show up here. So that was really cool. And then the tie rod, you set that diameter in the spreadsheet, and I just extruded that to the, the 2 plus 2 times the caps, but let's make that like 2.5 times the caps. And yeah, that's kind of the way that I did the parts. There's not a whole lot more to do. Like this, get this into this top groove here. Maybe the bottom one. Let's look at our reference image. Yeah, there should be a ring in there, and there really should be more seals. But, we're just keeping it simple for now. We're not going to throw that many seals in. I mean, it's easy to throw these seals in. And just a thought on manufacturing. You know, this can be done, the tree pan can be done in a mill. So let's say we didn't have any internal seals here. I don't know how, but that whole thing could just be done in a vertical mill. But with these internal bores, really what I think you would do is you would make a bolt, what do you call it? Make it like a holder that you would bolt, probably with this tie rod bolt pattern. You know, we could make those dowel holes and then mount it, you know, using 2 dowels or 3 dowels. Yeah, 2 dowels and 2 bolts, or something like that. Or one dowel, 3 bolts, and mount that to something that you would chuck up in a lathe. Or you could use a 4-jaw. I wouldn't. I mean, yeah, I mean, there's guys who use 4-jaws all the time for everything. So that was my thought on manufacturing these caps, because really the caps is all we would have to manufacture. The tie rods, maybe. And then the seals theoretically could be printed. But the caps is really the only thing that we'd have to manufacture. Everything else would be off shelf. Maybe that's assuming you're getting a piston, the tubing, and the ground rod off the shelf. Otherwise, you're manufacturing all of it. Okay, I hope that, like I said, I hope that this file is helpful.